All right, so we're going deep into AI today.
Oh, yeah.
A corner of AI that is just exploding right now. Computer vision.
I like it.
Specifically, how a new tool is making computers see the world in a whole new way.
Okay.
You've probably heard of AI that can write poems or code.
Right.
But what about AI that can understand a complex scene in a photo? Not just identify objects, but really grasp what's going on.
Yeah, like we do.
Like we do.
Exactly. That's where Transformers come in.
Okay.
They're changing the game in computer vision.
Okay.
To appreciate why this is so groundbreaking, though,
Yeah.
we need to rewind a bit.
Okay.
Traditionally, convolutional neural networks, or CNNs,
Right.
were the workhorse of computer vision.
Workhorse, how so?
Think of them as really good at recognizing patterns,
Okay.
but needing to analyze an image bit by bit.
So kind of like reading a book one word at a time?
Yeah.
Instead of grasping the whole sentence or paragraph.
That's a great analogy. CNNs were great for tasks like telling you, yep, there's a cat in this picture. But they struggled with understanding the context,
Right.
the bigger picture.
Okay.
Transformers, on the other hand, are designed to look at the whole scene,
Interesting.
understanding relationships between objects.
So you're saying they can tell not just that there's a cat,
Right.
but that it's chasing a mouse up a curtain.
Exactly.
That's a huge leap.
It is.
What makes Transformers so good at understanding these complex relationships?
Well,
Is it some kind of super-powered algorithm?
the secret sauce is the attention mechanism.
Okay.
It's not about processing information sequentially, like reading a sentence word by word,
Right.
but rather allowing the model to focus on different parts of the image simultaneously and figure out how they relate.
Okay.
Imagine you're at a busy party. Instead of only listening to the person right in front of you, you can also pick up snippets of conversations happening across the room,
Right.
getting a sense of the overall vibe.
So it's like having a 360-degree view of the scene
Exactly.
instead of tunnel vision. That's incredible.
This is where Transformers really shine.
Okay.
They can see how everything in the image interacts.
Wow.
No matter how far apart those elements might be,
Right.
it's this ability to process information globally
Yeah.
that allows them to grasp context in a way that was previously impossible.
I'm starting to see why this is such a big deal.
Yeah.
But how does it actually work in practice?
Well,
How do you feed an image to a transformer?
think of it like giving the Transformer a disassembled jigsaw puzzle.
A jigsaw puzzle.
First, the image gets chopped up into little chunks called patches.
Like the individual piece.
Like the individual puzzle pieces, right?
Okay, so each patch has its own code.
Yes.
But how does the transformer know where each piece goes in the big picture?
Right, you can't just throw puzzle pieces together randomly.
Right.
That's where positional encoding comes in.
Positional encoding.
It's like adding a location tag to each patch's code. So the transformer knows not only what each piece looks like,
Okay.
but also where it sits in the image.
So now the transformer have all the pieces it needs
Right.
to start putting the puzzle together.
Yes.
Understanding the complete scene.
Exactly.
So it's like the transformer is now looking at a map of the image.
Yes.
With each piece labeled and in its right place, ready for analysis.
Exactly. This is where the transformer encoder steps in.
The encoder.
It uses the attention mechanism to figure out the relationships between all those patches.
Okay.
Like a detective piecing together clues from across a crime scene.
Got it.
It analyzes which patches are most relevant to each other, building a multidimensional understanding of the image.
So this is way more sophisticated than just saying this image contains a cat.
It is.
It's about understanding the nuances,
Yes.
the actions, the story unfolding within the image.
You got it. And this ability to understand context opens up a whole new world of possibilities in computer vision.
A whole new world.
But before we get carried away,
Right.
let's unpack exactly what those possibilities are.
Okay,
Yeah,
let's
sure.
do it.
All right.
Okay, so we've got our image all chopped up
Right.
into these little patches,
Yep.
each with its own unique code and a location tag.
Uh-huh.
And now the transformer encoder steps up,
Yeah.
ready to analyze the scene.
Ready to go.
But how does this attention mechanism actually work?
Well, it's all about understanding relationships.
Okay.
The encoder doesn't just analyze each patch in isolation.
Okay.
Instead, it looks at how every patch relates to every other patch, figuring out which connections are most meaningful.
So, like, how do they figure that out?
Think of it like analyzing a social network. You're not just looking at individual profiles.
Right.
You're mapping out the connections, the friendships, the families, the influencers.
So the encoder is building a sort of relationship map
Exactly.
of the image.
Yes.
Highlighting the strongest connections between different elements.
It's like creating a web of associations. Okay.
Where the strongest links represent the most significant relationships.
And that's where the attention part comes in.
Exactly. The encoder pays more attention to the connections that are most relevant.
For understanding
For understanding the scene, right?
So it's not just about recognizing that two patches are next to each other in the image.
No.
It's about understanding if those patches actually have a meaningful relationship.
Precisely.
Okay, so can you give me an example?
Let's go back to our cat chasing a mouse example.
Okay, yeah.
A traditional CNN might just see the cat and the mouse
Right.
as separate objects.
Okay.
But the transformer, through the attention mechanism, can see that the cat is the one chasing the mouse.
Wow.
Understanding that dynamic between them.
Okay.
It can even pick up on subtle cues like the direction of the cat's gaze or the tension in its muscles.
That's incredible.
It is.
So it's like the transformer isn't just seeing the image.
Right.
It's understanding the story, the action unfolding within the frame. Exactly. And this is what sets transformers apart.
Okay.
They're not just recognizing patterns, they're inferring relationships, building a narrative from the visual information.
Okay, so this ability to understand context
Right.
opens up a whole world of possibilities, right?
It does.
Like it goes way beyond just identifying objects.
Absolutely. Let's take image captioning, for example.
Okay.
A traditional CNN might be able to tell you, this image contains a cat, a mouse, and a curtain.
Okay, very basic.
But a transformer,
Yeah.
thanks to its understanding of relationships,
Okay.
could generate a caption like a playful cat is chasing a tiny mouse up a floral curtain.
Wow, that's a much richer, more nuanced description.
Right.
It captures the action, the mood, the details that bring the image to life.
Exactly. And this level of understanding has profound implications for various fields.
Like what?
Imagine using transformers to analyze medical images,
Exactly.
not just to identify abnormalities, but to understand their context, their potential impact on surrounding tissues, and even predict how they might evolve over time.
That could revolutionize medical diagnosis.
It could.
Doctors can make more informed decisions,
Right.
leading to earlier intervention and better patient outcomes.
Precisely. And the applications go far beyond healthcare.
Oh, wow. Like what?
Think about self-driving cars.
Self-driving cars. Okay.
A transformer could analyze a street scene, understanding not just that there's a pedestrian crossing the road, but also that a cyclist is approaching from behind.
Wow.
Anticipate potential hazards and making split-second decisions to ensure safety.
That's incredible.
It is.
It's like giving the car a sixth sense,
Yeah.
a deeper understanding of the environment
Right.
that goes beyond just reacting to what's directly in front of it.
Exactly. And this is just the tip of the iceberg.
Wow.
We're only beginning to explore the potential of transformers in computer vision.
This is seriously mind-blowing stuff.
It is.
But with all this talk of revolutionizing various fields,
Yeah.
I can't help but wonder, are there any limitations to this technology?
That's a good question.
What are the challenges researchers are still grappling with?
You're right. It's important to acknowledge that while transformers are incredibly powerful, they're not without their challenges.
Okay.
One of the biggest hurdles is computational cost.
Computational cost.
Processing all those relationships between image patches requires a lot of computing power.
Oh, okay.
Especially for high-resolution images or videos.
So it's not just about having access to powerful computers.
Right.
It's also about finding ways to make the technology more efficient.
Exactly. Researchers are working on developing more streamlined transformer architectures, finding ways to reduce the computational burden without sacrificing accuracy.
Okay.
It's like trying to design a high-performance race car that's also fuel efficient.
That makes sense.
Yeah.
And I imagine data is another big challenge.
It is.
These transformers need to be trained on massive data sets to learn all those complex relationships, right?
Your spot-on data is the lifeblood of any machine learning model. And transformers are no exception.
Yeah.
They need to be fed vast amounts of labeled data to learn effectively.
Okay.
This can be a challenge, especially in fields where data is scarce or expensive to collect.
So it's not just about having the right algorithms.
No.
It's also about having access to the right kind of data.
Absolutely. And that's another area where researchers are focusing their efforts.
Okay.
Finding ways to train transformers more efficiently. Potentially using techniques like transfer learning or self-supervised learning.
I see.
It's all about making the most of the data we have
Right.
while exploring new ways to acquire and utilize data effectively.
So it sounds like there's a lot of exciting work happening in this field.
There is.
It's clear that transformers are already making a huge impact.
They are.
But it feels like we're just at the beginning of this journey.
I agree. We've laid the groundwork,
Okay.
exploring the core mechanisms of transformers and how they're revolutionizing computer vision.
Okay.
But the real excitement lies in what comes next.
I like it.
How will this technology continue to evolve? What new applications will emerge?
Right.
And how will it reshape our world?
So we've covered a lot of ground in our deep dive on transformers.
We have.
From the inner workings of the attention mechanism to the real-world applications.
Right.
But what has me really fired up
Yeah.
is where this is all heading.
Sure.
I mean, we've talked about self-driving cars and revolutionizing medical diagnoses.
Uh-huh.
But what other doors might this technology unlock? What's on the horizon for transformers?
Well, one area that's particularly exciting is the development of hybrid models
Hybrid models.
that blend the strengths of transformers with other approaches like CNNs.
So instead of seeing these as competing technologies,
Right.
researchers are finding ways to make them work together.
Exactly. It's like combining the best of both worlds.
Okay, so like how?
CNNs excel at capturing local features and textures, while transformers shine at understanding global context and relationships. So instead of seeing these as competing technologies,
Right.
we're finding ways for them to work together.
Kind of like a dream team of AI approaches.
Exactly. And this collaboration is leading to some remarkable advancements.
Like what kind of advancement?
For instance, imagine a system that uses a CNN to efficiently identify potential objects of interest,
Okay.
and then employs a transformer to analyze the relationships between those objects, leading to a more nuanced understanding of the scene.
That's fascinating. It's like having a specialist who can quickly scan a document for keywords,
Yeah.
and then a detective who can piece together those keywords to solve a mystery.
Another area that's really heating up
Yeah.
is the application of transformers to 3D vision.
3D vision.
Up until now, we've mostly focused on 2D images and videos.
Right.
But the real world, of course, is three-dimensional.
Right. And understanding depth and spatial relationships in 3D
Yeah.
is crucial for so many applications, especially like robots navigating complex environments
Right.
or creating immersive augmented reality experiences.
Absolutely. And transformers are showing great promise in this domain.
Okay, how so?
They can analyze 3D point clouds,
3D point clouds.
which are basically collections of data points that represent the shape and position of objects in 3D space.
So it's like giving the computer a 3D scanner that can capture the world around us
Yeah.
in incredible detail.
Precise.
So instead of just it's a flat image,
Right.
the computer can now perceive the world as a collection of 3D objects,
Yes.
understanding how they relate to each other in space.
Exactly. And this unlocks a whole new level of understanding.
Give me an example.
For example, imagine a robot navigating a cluttered warehouse
Okay.
with 3D vision powered by transformers.
Okay.
The robot can not only avoid obstacles, but also understand the shapes and positions of objects,
Yeah.
enabling it to grasp and manipulate them with precision.
That's incredible. It's like taking robotics to a whole new level.
It is.
From simple movements to complex interactions with the physical world.
Right.
That's incredible.
And those possibilities extend far beyond robotics.
Okay, far beyond robotics, like what?
Think about medical imaging.
Medical imaging.
With 3D vision,
Yeah.
doctors could analyze scans with unprecedented detail, understanding the spatial relationships between organs and tissues,
Okay.
leading to more accurate diagnoses and personalized treatment plans.
It feels like we're on the verge of a paradigm shift
It does.
in how computers perceive and interact with the world around us.
Yeah.
But amid all this excitement, I think it's also important to step back and consider
Yeah.
the broader implications of this technology.
Right.
What kind of future are we shaping with these advancements?
You bring up an important point.
Yeah.
As with any powerful technology,
Uh-huh.
there's a responsibility to ensure that it's used ethically and for the benefit of humanity.
Right.
One of the key challenges we need to address is the potential for job displacement.
Yup.
As AI systems become increasingly sophisticated,
It's a valid concern as machines become capable of performing tasks
yeah,
that were once exclusive to humans.
Yeah.
It's crucial that we invest in education and retraining programs
absolutely.
to help people adapt to the changing job market.
It's about empowering people to work alongside these intelligent systems,
Yeah.
leveraging their unique human skills,
Right.
creativity, critical thinking, emotional intelligence.
It's not about replacing
Oh,
humans.
no.
It's about augmenting their capabilities and creating new opportunities.
It's a future where humans and machines collaborate,
Uh-huh.
each contributing their strengths to solve complex problems and drive innovation.
And beyond job displacement, there are other ethical considerations,
There are.
like ensuring fairness and preventing bias in AI systems.
You're absolutely right. It's essential that these systems are developed and deployed
Yeah.
in a way that benefits all of humanity, not just a select few. We need to be mindful of the potential for bias in the data used to train these models
Okay.
and ensure that they're used responsibly and transparently.
It's a reminder that as we push the boundaries of technological innovation,
Yeah.
we also need to engage in thoughtful discussions
Hmm?
about the ethical and societal implications of our creation.
We do.
We need to shape a future where technology serves humanity, not the other way around.
Well said. This deep dive into Transformers has taken us on quite a journey.
It has.
From the intricate workings of algorithms to the vast potential and the ethical considerations
Yeah.
that come with such transformative technologies. And as we wrap up,
Yeah.
I'm left with a sense of awe and cautious optimism.
It's been a fascinating exploration, and I hope our listeners are now just as excited as we are about the possibilities
I hope so.
and the challenges that lie ahead.
Yeah.
And as we conclude this episode, we want to leave you with a call to action.
Oh, yeah.
Keep exploring, keep questioning,
Uh-huh.
and stay curious.
Good.
The future of AI is in our hands.
It is.
And by engaging in thoughtful discussions and responsible development,
Yeah,
we can shape a world where technology empowers us all.
absolutely.